Hi everybody, very good evening to the guys who are joining us from India, and good morning to the folks joining us from US. This is Vishal, Krishna for this webinar. You don't need any knowledge of Java for this webinar. Anyway, this was just his question that do I need to have Java knowledge to be here? You definitely don't need. Okay, Krishna, I hope you got the answer. Okay, guys, so sharp 9:01, and let's just get started because anyway, this entire webinar is kind of 1 hour, and there are quite a few things which I definitely wanna kind of share with all of you, right? So, okay, guys, so just getting started. Hope everybody is able to see the screen, my screen right now in the full screen mode, which talks about Spark. Some basically 5 topics or 5 things one must know about Spark, and they are again at a very high level. Okay, so just quickly getting started about, so before I get started about the topics and other stuff, let me just quickly introduce myself. So you know my name, Vishal. Uh, when it comes to the number of years of experience, it's now more than 12 years altogether. And since last more than 5 years now, yeah, 5 years plus actually, in big data domain, so-called big data domain, because when we started, there was nothing like big data as such. These were like just disruptive set of technologies, and Hadoop being one of the sub-projects in Apache. So that's how the journey is, and eventually it evolved, Hadoop. Then eventually we saw that it getting the enterprise acceptance, and then eventually turning out to be an enterprise platform. And then we started seeing more and more requirements in terms of some of the faster batch analytics or real-time, near real-time analytics. And then likingly or unlikingly, basically I had to get involved in starting with the newer frameworks altogether, some of them being if you have heard about it, like Storm. Spark is something wherein I'm working since last now more than 1.5 years, I would say. Um and then when it comes to some other frameworks like Samza and all, so those are few of the things wherein I work. And currently I end up doing more of that. If you have heard of something called Lambda architecture, so Lambda architecture implementation at the enterprises, it's all about the coexistence of the big data systems with, or near real-time systems with the existing legacy systems altogether. Well, that's, I think that should be good enough introduction for seeing that it is just 1 hour thing, right? So I should not be eating up more time on my introduction on this side. So now coming to the things which we just, or 5 things which you definitely should know, right? Uh, some of you, I mean, of course, the right now, this webinar, just as an information, is having almost 90 people already, and people are still joining. So there are 90 people already logged in into this webinar. And so, of course, I'll try my level best to answer your queries as well. But as you can understand, in the interest of time, I'll try to batch and I'll try to see what are the most common queries and if I could answer. But nevertheless, you are seeing a handle here, edureka.co/Apache Spark Scala training. If you have something more, some more queries which probably were not handled in this, webinar, you can always drop us there. Okay. So, very quickly, at the end of this webinar, there are these 5 things which we definitely want to at least discuss. There's something called, Spark. If you would have done a bit of Googling by yourself, you would have found that the main differentiator for Spark from the system like Hadoop is primarily, the USP is low latency, right? So we'll quickly talk about that. Streaming support. This is another important thing which makes Spark unique. Um in the proposition of other big data systems altogether, because there are other big data systems which are quite specialized, which just do streaming, for example, Storm. But Spark does streaming also. It is not like Spark does only streaming, right? So we'll quickly discuss about that. And at that point of time, I'll try to address some of the things like what are the kind of operations which are possible, okay? What are the kind of operations which are possible using Spark streaming, and eventual comparison, inevitable comparison with the Storm. So I'll try to see if I can address some of those things there, right? And after that, it is about, the other thing which we would like to discuss very quickly, machine learning and graph. So these are the two new features which you should be watching, which you should be looking at, because they are right now in the alpha release or pre-alpha releases. Very soon, they are going to be kind of in a production ready kind of an environment altogether, right? So that would be something which we'll discuss. And then DataFrame API introduction. Well, this is a remarkable feature which has been added with the latest release of Spark, that is Spark 1.4. Okay, so what are the implications of it in the entire landscape of Spark itself? Those are the things which we'll discuss under this topic number 4. Last but not the least, Spark integration with Hadoop. Even though the slide would be talking at the higher level, but I would like to go at one level deep in terms of what are the different ways in which you can integrate with Hadoop. That is something which we'll discuss. So seems like a good utilization of your time, guys. Let's just get started, right? Great. Yeah, for us, so I will just answer your question at a certain stage. For us, Somin was saying, can you please start with what is Spark? Is Spark inbuilt component of Hadoop ecosystem? Well, Somin, I hope you just got the answer that it is not the inbuilt part of Hadoop ecosystem. It is different. So just getting started on Spark itself. I hope everybody is able to see the slide which talks about Spark architecture. But before I jump into Spark architecture, as I hear from Somin, and there must be several other people also who first would like to know what is Spark, right? Seems like a valid question. You can say yes or no also, right? If it strikes, like if it seems like a valid question to you, right? So the first thing, the first thing first itself, okay? Uh, when it comes to, so here, before I answer this question, I will take some assumption that you guys at least are aware of big data domain and you have heard about Hadoop, right? So let us, that is the basic assumption which I'm taking, okay? So for that, um, if you know about Hadoop, it's a cluster computing system altogether, right? Which allows you to do the distributed computing, and it's kind of a framework which gives you various utilities to store your data as well as process your data in a distributed fashion, right? And that eventually results into HDFS and then eventually to MapReduce, right? So that is something which is the basic definition of Hadoop. Well, we are talking about Spark here. So Spark does the same thing. Spark does exactly the same thing, barring the storage side. Spark doesn't care about storage. We will come to that why, okay? But it primarily focuses on the processing side. So where's the difference? The difference is Spark does these operations in memory, okay? In the distributed fashion. So when you talk about in memory, of course you cannot load 1 terabyte of data in a single machine, right? You cannot load all of this data in a single machine in the memory. So Spark supports loading as well as processing of the data in the in memory, and which is distributed across different nodes. So they can share the context also. That we typically call that as Spark context. That is a big USP, because in that case, your operations in certain cases, I'm not saying this is the benchmark, but in certain cases, we have seen performance like almost 100 times faster also, and even more in some cases, right? So, but yeah, it's a fair assumption that it is with the orders, your performance gets improved altogether, right? So this is about a very quick definition of Spark, right? That is just to set the context. Now, coming to the architecture of Spark altogether, you might be seeing different colors, and I can see that there are people who are pinging, hey Vishal, why these different colors? What is this color coding all about? So let me just quickly tell you few things here. Okay, Spark is kind of a platform, or rather than platform, I would say it's kind of a framework altogether. Just like you say, Hadoop is a framework, right? Similarly, Spark is also a computing framework. Okay, so at the heart of this framework, as you can see at the bottom line, there is something called Spark Core, right? Spark Core, which is a processing engine. That's a core Spark API. Okay, the core Spark API is internally written in Scala language altogether. Okay, and hence even so in Edureka we typically, or we can cover this entire Spark thing into Scala language altogether. Okay, we do it via Scala language. So now coming back here, so this is the core Spark API, wherein you can write the programs, right? You can write the programs in your core Scala language altogether. It is not just limited to Scala. You can use Java, you can use Python as of now, and and Spark has taken the step to integrate itself with R language also. R is a statistical language. Okay, so it is not yet production ready, of course, but it's like active development is on, and very soon there should be a production ready release altogether. But they have taken a decisive step in this direction by introducing something called data frames. We will discuss about it. I think whenever we'll talk about I think the topic number 3 or 4, at that point of time we will be discussing about data frames. But yes, the whole idea is the core Spark API itself is polyglot in nature. You can use any of these popular languages, Java, Scala, Python, or R, to interact or to code your programs in Spark. However, we strongly suggest to use Scala because of the very same thing, right? You talk about native MapReduce in Java because Hadoop is written in Java. The same philosophy goes here as well. But it is not just that. There are other advantages because Scala is a much more powerful programming language as compared to Java also when it comes to the programs which are supposed to run in the distributed environment. So of course the focus is not those capabilities of Scala in this webinar, but you can always explore on your own on those sites, right? So this was about core Spark engine. Well, uh, so core Spark engine is something which is which is exposed by any of these languages. But guys, if I ask you what is the main reason for Hadoop to be so popular in the enterprise domain or in the big data batch processing domain, what will be your answer? What do you think is going to be your answer? It is going to be, it's not low cost, as Somin is saying, not MapReduce. No. Not this exactly. The main reason is, guys, the main reason is Hadoop has not limited itself to just the programmers who can code in Java, right? If you know, you can do Hadoop streaming. Via Hadoop streaming, you can write your programs, let's say in Python, in Ruby, even in C++ and all that, and then you can write your MapReduce programs, right? That is part one. The second part, and the most important one, is it has not limited itself to just the programmer community. So what I'm trying to say is, you are a programmer, write your MapReduce. You are a person who comes from the SQL background or data warehouse kind of a background, Hive is there for you. You can still write SQL and leverage the power of Hadoop, right? You are a person who is from the data flow kind of a background, you know, that kind of a background, then you can use Pig, right? So basically, depending upon which kind of background you come with, you always have something to explore, right? Do you guys agree? Right? That is something Hadoop supports. Hadoop, there is something called Hadoop streaming, Murthy. Just try to explore on those lines. That streaming doesn't mean real-time streaming. Okay, Murthy? Just to give you the idea about it. Search for something called Hadoop streaming. Okay. Now, let me just come back here. So that is something which is one of the main reasons of popularity, apart from the things which you have mentioned, commodity hardware and scalability and blah blah blah. All of those things, I'm not even going in those directions. They are well known, right? Now coming back very quickly here. So this Spark core. So this, in the same way, Spark also, as you can see here, there is something called Spark SQL. There's something called Spark Streaming, MLlib, Graphx, right? So these are the different wrappers of Spark core Spark API. Okay, so it's like your Spark SQL is kind of a SQL package which is developed on Spark. So those people who are from Hadoop background, I'm sure you can easily correlate it with Hive, right? Hive is the SQL wrapper on the top of MapReduce, isn't it? Aren't you seeing a pattern now? I hope you are able to see the pattern here, right? So this is the SQL wrapper. Well, there is one most important thing here is that this particular Spark SQL is fully compatible with Hive. You know what does it mean? It simply means that if you have some of the production systems wherein you are running your Hive queries, you can run them as it is without any change of code in Spark SQL. Just that they will run way faster. That is one of the main USPs. Okay. So Ambati, there is a nice question from Ambati. Ambati, it is a live webinar. The fact that I'm answering your question is that it's a live webinar, right? His question is that whether it is a live webinar or is it a recorded session. Okay, so okay guys, so coming back here very quickly. Yeah, so coming back to this point, so Spark SQL is all about being the SQL package or the SQL engine of Spark. Okay, so being the SQL engine of Spark, wherein you can explore the structured data using Spark, using your you know, HiveQL itself. Uh, it has, so you can see there is something called DataFrame on the top of it, right? This feature, this orange color thing, DataFrame, is something which has been introduced in Spark 1.4. Somebody was asking a question, what is the current version in the market? So guys, Spark keeps releasing its version every fortnight, okay? So when I say every fortnight, every 2 weeks, there is always a version. So it completely depends, but yes, 1.4 is a marquee release because they have now started taking the step towards Spark R, wherein they have said DataFrame is your unified access of data. We will come back to DataFrames at some slide later, but yes, now all of the data which is, you know, structured can be exposed in the form of DataFrames altogether. Okay. Next is Spark Streaming. So this is the utility wherein you typically have those kind of windowed operations, right? I will just give you the hints about, like, you must be following some IPL events, or recently we had World Cup, or I'm a cricket fan, so I'm just giving those examples. Typically, you have those kind of scenarios wherein the trending team, the player which is being most talked about, right, just before a match. So the player who is most popular 1 hour before the start of match, within 1 hour of the match, after 1 hour of the match, they might be different, right? So they are typically the windowed operations, right? Again, they are like very, very common kind of examples at the enterprise level, and the examples might be different. But yes, if you have these kind of scenarios, they are more real time. Your number of tweets on Twitter would be too huge, but you have to identify who is the trending player altogether for a particular hashtag, right? So these are the kind of scenarios wherein typically people typically use something called Spark, Storm and all. Here, Spark enables you to do this using something called, just a second. Guys, are you all able to hear me? Are you all able to hear me, guys? Okay. So for us, this was a problem at your end. Great. Thank you. Thanks a lot, guys, for confirming, because there were few comments like we were not able to hear. That happens. No problem. Okay, so coming here. So Spark streaming is something which enables you to do those streaming kind of operations, real-time streaming. Probably Murthy was referring this, right? Sometime back. MLab, you want to do some sort of machine learning or graph processing. You have the Graphx kind of, packages which are available. However, guys, let me put that, disclaimer here. So MLab and Graphx, as of now, they are in the alpha or pre-alpha releases. They are not yet production ready. Okay, so they are not yet production ready. Their APIs are available, but they are subject to change. They are subjected to change. Okay, so they keep changing. So as of now, when it comes from Edureka side, we show only the portions which are production ready, right? There is no point in showing something which you can't go back and apply altogether, right? So that is something which I want to very, very clear, I want to be very, very clear at this point itself. Uh, and now, so I think, yeah, before I proceed forward, there are few questions, I think. So, uh, so Spark streaming is equivalent to Storm? The answer is yes. This question came from many people. How Spark is doing very fast processing? Probably it is coming from people who kind of missed the initial part. So I told you that it does the in-memory processing in the distributed fashion using something called resilient distributed data sets, or RDDs. Okay, that's the reason for its very fast processing. I hope these are some of the trending questions, I would say, and I hope you got the answers, right? Sorry if I'm missing some of your individual questions, but there are now more than 130 people right now. So, please, right? Now, so this was about the architecture part of it. And as you can see that, just a sec, let me just go back. So apart on the top of this core Spark engine, all of these packages are typically helping you, okay, are going to typically help you to do various kind of, whatever objective you want to achieve, right? You want to do structured analysis of the data, you want to do some sort of a streaming kind of a processing, you want to do some sort of graph processing, all of those angles are possible. Well, there are some guys who are asking about you. What about the ML lab pipeline or ML pipelines, guys? These are the. It is not MI pipeline. This is machine learning pipeline. They are all enabled by the combination of machine learning plus graph processing, right? You can create those things on the top of it, right? And hence these are the things. Well, there is one thing which I didn't mention, that is at the last. If you remember, I was talking and telling you that Spark is typically the processing model. The reason is it can connect with any of the data sources. You want to get the data from local file system, from a messaging system, from HDFS, all of those data sources are supported, right? So those are few things, right, which kind of I just wanted to continue, discuss in this slide. Then comes the low latency part. So again, now these are some of the things wherein you know uh, they should uh, basically give you some idea about how exactly Spark takes care of these huge amount of data or things like that, right? So guys, the first thing first, Spark basically cuts down your read or write in IOs from disk, because Spark stores its data, okay? The Spark stores its data in the form of something called the RDDs, okay? Resilient distributed data sets. And they are nothing but in-memory collection of the data which are distributed across the across the machines. However, there are some of the limitations of that also, okay? Of course, if you have like 10 terabyte of data, you cannot load all of the data in the in RAM itself, right? So there are some of the best practices about it. There are certain stages wherein you can create those checkpoints and keep those kind of data cached in memory. However, again, there might be some people who might be thinking, well, Vishal, even if I do some sort of filtering, I do some sort of, let's say, column pruning and all, still my data is kind of, let's say, 64 GB. Are you saying I can load the entire data in memory? Well, the answer is, of course, no. You cannot load all of this 64 GB data in the memory, especially if you are kind of running into, with a low configuration, right? So in that case, what you Spark gives you the tunable storage. So you can say, and this is the unique feature about Spark, 100% of my data is going to be in memory. Or you can say, let's say 80% of data in memory, 20% in disk. Or, vice versa, right? 20% in memory, 80% on disk. Based on whatever infrastructure you have and whatever kind of, storage you are choosing, your performance can be tuned from very fast to a bit slow or quite slow also, right? At the end of the day, processing model also needs infrastructure support, right? So those are few of the things, right? So RDDs are typically used for your real-time analytics, whereas Spark can fetch the data from HDFS storage also, but in that case, you are typically going to use Spark for faster batch analytics. So there are a few questions like, does Spark handles terabytes of data? Answer is yes, but it's not like you take 1 terabyte file and load it. Of course, you will not do that, right? So, or if you really have that requirement, then your cluster has to be a bit big. You cannot expect 1 terabyte of data to be loaded in Spark in a single node, right? So that, and hence goes the answer, right? Next, now these are some of the facts. I typically call them as some of the fact slides rather than anything else, right? So how fast a system can sort 100 terabyte of data, right? Well, these are some of the things rather than me talking about. Take few seconds, right? Take few seconds, read at the slide. So as you can see that MapReduce was very good. 100 terabyte of data, by no means it's a small volume or even just a large volume. It is very large volume of the data which we are talking about, right? But 100 terabyte of data was kind of, you know, uh, processed in 72 minutes on 2100 nodes, whereas the same amount of data, when you started using Spark, and only 206 nodes as compared to 2100, please look at the numbers, right? 2100 as opposed to that, it is 206 nodes. All of 100 terabyte of data got sorted. TerraSort, I hope if you have not heard, please, you can Google out for TerraSort algorithm. Basically, it's all about, sorting huge amount of data. So that got completed in 23 minutes. So Spark eventually sorted the same amount of data 3 times faster using 10 times lesser machines altogether, right? And that is something, of course, you're talking about 100 terabyte of data. So this 100 terabyte of data definitely can't be processed in memory, even for Spark, right? So hence the last line. All of the sorting took place on disk without using Spark's in-memory cache. Okay. So only the processing has happened, not storage part has happened in the memory. So just, I mean, these are the numbers which you can search on net itself rather than, just looking at the slide also. But yeah, I just wanted to give you some idea about the benchmarkings on the similar kind of, yeah, when we are talking about the benchmarking stuff, right? So yes, so Ambati, I think that is something which you are looking for, right? Isn't it the thing which you were asking? What is the configuration? So well, please have a look of the configuration. And they are like apples to apples comparison. They are apples to apples comparison in the sense, MapReduce jobs also had the same configuration, right? So 100 terabytes of data, how many seconds? I'm not a big fan of reading the slides, right? And at the same time, you should not just be listening, right? You should be processing your thoughts also, right? Looks good? I'm just proceeding forward because they are more of the information slides rather than the concept kind of slides. Just proceeding forward, and we have mentioned all of our sources here, sortbenchmark.org. Okay, so they are like publicly available data which we are showing. Next, streaming support. Yes, I'm sure the moment I talk about streaming support, there must be at least 20-30 people in this room. When I say room, our virtual room, that who would be interested in knowing about it, right? So guys, streaming, as I was just telling you, that we typically use it for real-time streaming data. And just that, I was telling you that RDD, right, resilient distributed data set, is the secret of fast processing, right? When it comes to Spark streaming, Spark uses something called DStream, or the full form of DStream is discretized stream. By the way, what is discretized stream? Discretized stream is nothing but the collection of RDDs, small RDDs, which are created every, let's say, few seconds, which are configured. Okay. Okay, guys. So yeah, I was at the point wherein discretized stream, right? So it's all about the series of RDDs which are created, and eventually your streaming kind of programs. So these kind of programs are typically different in nature from your from your typical batch programs, because you talk about Hadoop program, right? MapReduce. What do? You submit your program, it runs on the cluster and stops, right? Processing over. Till the time you run it again. With the streaming kind of programs, again, whether you're talking about Spark streaming, or if I am permitted to go slightly off the topic, like even the programs like Storm, right? They use something called topology. They are the programs which keep running on cluster or whatever distributed system you are running them on endlessly. So you submit a program, it will keep running again and again and again and again. It's like your cron job, but scheduled, let's say, every 1 second, every 2 seconds, sort of, right? And then until and unless you go ahead and explicitly kill them. Okay. So in this process, they keep on processing the data in small chunks, right? Like some data with whatever got accumulated in last 2 seconds. Nothing came, so program just runs, doesn't process anything, and then sits idle, right? So eventually, these kind of systems are used for something called event processing itself, right? They are typically used for event processing kind of systems, right? So Spark, through Spark streaming, all of the event processing kind of event processing kind of scenarios are supported, which are typically almost same as Storm, right? Apache Storm. Oh yeah, there is another question, interesting one, which I can see from many people, that is Spark an Apache project, or is it open source? Yes, answer is yes to both of them. Apache Spark is open source, and since I'm using Apache, so it's an Apache project anyway. I hope I I can't recall who, because there are so many people, but I hope you have got the answer, right? Uh, Sorry, and again, there might be a lot of people who might be thinking that my question is not being answered, but I can just take few of the repeated questions only right now. Okay, machine learning and graph implementation. Yes, before I come and talk about machine learning and graph processing, I want to repeat myself here. Okay, I want to repeat myself here because I was telling you at the some minutes back that machine MLlib and Graphx are not yet production ready. Right now, they are from the capabilities perspective. There are developer APIs which are open. So of course, people are experimenting. They are still in the process of evolution, and eventually, things are just getting in place, sort of, right? So, but yes, they are under active development. So MLlib, it's kind of a machine learning libraries. Uh, how many of you have heard about Mahout, Apache Mahout? It's a machine learning library which is developed on the top of Hadoop, right? Can somebody tell me what is the latest release of Mahout? Please do not Google out. That's not my intention. That is not my intention, right? Do you remember? Okay. So let me just tell the I also don't remember. Now, why am I asking? The reason is pretty simple. The release of Mahout has happened several months back. Okay, so why is this point relevant? Because all of the latest, or those implementations, the team has decided not to go for the further releases. Eventually, all of those algorithm implementations are being ported to MLlib, because it uses Spark internally and it runs many times faster. I hope if you have heard about machine learning, or if you have slightest idea of machine learning, you must be aware that these are the algorithms which are many times recursive in nature, or repeat or iterative in nature, right? K means clustering, right? I want to do iterations 10 times. What does it mean? It means that I have to go through the data. I have to pass through the same amount of data 10 times, 20 times, 50 times. Hadoop is not the best use case for it. So even if you run your MapReduce programs, for machine learning, they are going to run very slow. So eventually, Spark is the best, or is one of the best use cases for machine learning, and eventually this is the current state of affairs altogether. So be it your classification kind of algorithms, or regression, clustering, collaborative filtering, and so on and so forth. This list is still exploding altogether. Those are currently being ported. Some of them are even available. You can even go visit spark.apache.org, try your hand on some of the developer APIs. You can try some of them, but yes, signatures are subjected to change. That is something which I would like to call out very, very specifically. Okay. Uh, just a second. Hadoop may die. Ambati. Okay. And Ambati is requesting me that please answer my query. No, 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 no. Ambati, please do not assume this thing. Okay. If this would be the case, probably I would have changed the subject of this webinar saying that Spark replacing Hadoop. Okay. So I can just answer only in this line, right? Ambati? More on that, I'll try to answer when I'll talk about Hadoop integration. Okay, Ambati, that's the fastest which I can answer in this already, like short of time sort of webinar. So can we not use Spark ML Live in production? In production? No, not in production as of now. But if I understand it correctly, they are like kind of porting, and probably the kind of timelines which are being given are sort of, let's say, early next year. Early next year is 2016, somewhere Jan Feb is the time when they kind of say that yes, now your libraries are in place. Okay, so that is something which I just want to clearly call out. Mazhar. And not only Mazhar, I think there are so many people who kind of asked this question. I hope you got the answer. Okay. Next. So this was about one thing. Yeah. Another important thing. I think there were people who were asking what is the reason why Spark works so fast. So there was one thing which should be very, very clear by now, that RDDs, right, in memory processing, they alone cannot solve all the purpose. Okay, so just the in-memory processing cannot solve all of the purpose, because it's pretty simple to understand that even if you do the in-memory processing, and if you write bad enough program, okay, bad enough program, you can still screw up the things. Am I right? I mean, every language gives you those kind of capabilities, right? Positive, negative. So the same thing goes even true for Spark. So just the in-memory processing is not the answer. Spark, I'm sure some of you or many of you probably would have worked on something called Apache Pig, right? It's a data flow language of Hadoop. If you remember, if any of you has worked on it, you would have you can recall that it creates a directed acyclic graph of your operation. When you say A is equal to load some file, B is equal to for each whatever relation it is, and do some transformation, then eventually do some filtering and aggregation or whatever you want to do, right? Eventually, Pig creates a directed acyclic graph of all of your operation, and in that process, Pig tries to optimize the things. What it does is, I'm giving the example of Pig while talking about Spark because Spark does the same thing. Okay, so all of your operations, right? Your data operations, like loading the data, like filtering the data, like grouping the data, like joining the data, like partitioning the data, splitting the data, right? All of them are the operations which can be done on the data. Pig tries to optimize them. It sees, oh, you're applying two filter operations on the same data set, right? Just a second. Guys, are you all able to hear me? Because there are two people who are saying that they are not able to hear me. I just want to check. Okay. So there are people who are continuously able to hear me. Sure. Guys, this might be, but no problems. That helps me to know that yes, so many people are facing their individual, end problems. No issues. Let me just continue. Right. Okay. So let me just continue here. So yeah, I was at the point that Pig tries to see that, oh, are you doing two filter operations? Let me do them in single step for you. Are you doing filter as well as transformation? Let me do it in a single step for you, right? That is optimization. So I'm not sure if how many of you have worked with pig, but pig typically tells you the MapReduce plan before optimization and MapReduce plan after optimization. Okay, it does these two things. I hope, does anybody remember? Has anybody seen that? Has anybody seen that happening? If not, then try to run, if at all you work on those lines. Just try to run and look at the logs once. Okay, look at the logs once. Uh, Spark does the same thing. So entire effort of last few minutes was just to tell you that this directed acyclic graph gives the opportunity to Spark, okay, gives the opportunity to Spark to optimize your program by reducing or by combining some of the operations in single step. I hope you got the idea, right? Then that is what this slide says, and by now you would have figured out that at least I'm not a fan of reading the slides. Okay, and then the same capabilities, okay, then the same capabilities get extended when you talk about graph processing also. Okay, even though we are running short of time, guys, I hope it should be okay if I extend by, let's say, another 5 more minutes, let's say up to 10:05 p.m. or 10:10. That should be fine, right? Because my effort is right now to discuss few things with you. With this liberty of time, I just want to ask you one question. MapReduce, I'm sure many people have worked, and please forgive me if you are not aware and I'm asking this question, but those people who are aware of MapReduce, uh, have you, so if I ask you to do a depth first search, right? Depth first search of a graph in MapReduce, what is your answer? Can you do it? Or can you not do it? This is my favorite question for interviews also. So breadth first search, can you do it in MapReduce? I'm looking for your responses, guys. You can say yes, no, I don't know. Everything is there. Uh-huh. Okay. So most of the people, as they are saying no or no idea. So guys, the answer is no in the straight terms. And why no? Because they are the kind of algorithms which want you to know the previous states, right? Who was the parent, who is the children, and then whatever level, right? In the straight terms, no. But it is possible with some hacks. So there is something called, those people who are not aware, you can search for something called iterative MapReduce. Okay, search for that, you will get the answer. Eventually I had to implement it for Citi. So now you know I have worked for Citibank also. Okay, so if you do iterative MapReduce and a technique called perfect denormalization, okay, you can do the graph processing. Okay, but what is the point I'm trying to deliver? The point which I'm trying to deliver is, you, even though you can do, it is still a hack and it is very painful. Okay, it is a very painful job altogether. So these are some of the cases where MapReduce really becomes a pain. It really becomes a pain. That's all I would like to say. Okay, and those are the places, because of the nature of Spark of doing the processing in memory, and now you are no more limiting yourself, you know, uh, for the state which you can maintain, right? It is suitable to do graph processing algorithms. So whether your typical page rank or connected component, you know, friends of friends of friends, sort of, if you have heard about Neo4j database, right? So those kind of queries, Cypher is the language, right? Cypher is the query language for Neo4j graph database, right? So those kind of Operations which are typically done by these kind of NoSQL databases and all can easily be done by Graphx. Well, at the same time, let me repeat, it is still under development. So it is easier said than done right now. Just wait for some time. It would be the next big thing altogether. A complete paradigm or a complete set of algorithms can be unlocked by Graphx. I hope it is helping you guys to at least know the capabilities, if not anything. Just proceeding forward, guys. I am just proceeding forward now. And it's about support for, uh, yep, support for data frames. Well, this is something which I was just saying that I want to discuss. Guys, data frames is something which is introduced in version 1.4. Spark 1.4 onwards, data frames were introduced. So why am I talking about it? There are two things. Do you remember I was talking about Spark SQL? And I was saying that for structured data analysis, you will use it, right? I hope you are able to recall that. Some minutes back, I was talking about it. Up to Spark version 1.3, this Spark SQL was using something called schema RDD. Okay, schema RDD internally. That was the basic building block. From version 1.4 onwards, they have started using data frames internally. So the internal storage unit itself has changed now. Okay, so just keep that in mind. Okay, now what does it mean? So data frame is not just the change of unit. Okay, so with and yeah, another point which you should remember is that now your Spark SQL code from version 1.4 cannot run. There is no backward compatibility. It cannot run, let's say version 1.3. The syntaxes have changed completely because of data frame. Okay, so this is just another kind of a pointer which I wanna, if any of you are kind of evaluating or trying your hands on this, just keep that factor in mind. Okay, now coming back, so it is not just the change of unit. Okay, it is not just the change of unit, it's a longer step. What they have done is, you can read the slide in the meantime if you wish to, but the original intention is have the data frame which acts as a unified access. Okay, what does it mean? That whether you are loading the data via SQL, load it in data frame, or you are loading the data from a file, load it again in the form of a data frame, or tomorrow, when they are going to give the support for R. Okay, R works heavily on data frames, by the way. So whether you are giving the support for R, again they are going to access the very same, same sort of a data structure called data frame. And the next level was what they want to do. They want to give you the capabilities. Let's say write a Spark program, store the data in the data frame, persist it, and access it via Spark SQL, or vice versa, via Spark SQL, write some query, and load that query result, since it would be in a data frame, into R, do some processing, and do something else. You know what are we talking about now? You know what are we talking about? We are talking about PL SQL type of capabilities, right? Because Hive gives you SQL capabilities. When you manipulate the data along with querying, you're talking about PL SQL type of capabilities. That's a bigger footprint, that's a bigger plan to do in a very transparent fashion, right? Guys, I could have read the slide, but this is the gist, which is the roadmap going forward. I hope it is helping you guys to get the bigger picture, right? Saying that Just saying that data frame is introduced, but understanding why it is introduced and what is the roadmap, that is something which I wanted to deliver, right? Also, since you're talking about data frame on the distributed way, whether you are loading only KBs of the data or petabytes of the data, doesn't matter. Okay, it doesn't matter. So that is something, because underlying thing is all about RDDs thing, right? Um, uh, APIs for Python, Java, Scala, R, and you can see that in development via Spark are there are few things which are happening here altogether. Data frame is for the structured data. Yes, of course. Data frame is the manifestation of tables in R language. So in R, typically they are like, I mean, all I would say is just like a table, right? So they will help you. You can always name the columns just like a table column, access them, and all that stuff in a very dynamic fashion without storing them in the form of, or without the need of any metadata layer altogether, right? So that is something. I think I'm at the last topic for the webinar, that is about Spark can use HDFS and Spark can use Yarn. Okay. Now, those things, these are two statements. Somebody was asking, I think, I'm not sure whether it was Ambati or it was somebody else, Hadoop gonna die. I saw that statement. There are few people who are saying few years down the line, there would be people who would not be writing MapReduce, right? There were some statements like this, right? So let me tell all of that, no, those statements are invalid. Okay, those statements are invalid. Now, why invalid and all? Guys, remember, batch, so the kind of problem statements which you are trying to solve via MapReduce or via Hadoop are typically the batch processing. Am I right? That is something which you are trying to solve. And well, if in the batch processing, who cares whether you got the result in 20 minutes or whether you got the result in 25 minutes? Doesn't matter, right? So of course, or for that matter, let's say you got the result in 2 hours versus 2.5 hours, right? It doesn't really matter. So for those kind of use cases, you are still going to use MapReduce. It's not going to be replaced. However, most of the sensitive data loads, right? Time sensitive data loads or near real time batches. For example, the server data or server logs which are coming real time, you just want to kind of keep on visiting them, keep on taking some action on the top of it. Or in retail scenario, right? I'm sure you must be aware of something called dynamic pricing. If you have seen, let's say in Amazon and all, you check for a mobile, morning time probably the price would be 16,000. By evening, the price might go up to 15,000. By night, it might be back to 17,000 or something, right? They are the typical examples of back-end systems like dynamic pricing. Okay, so I'm just giving you those examples because, um, of course, now you would have guessed that I had to be involved in some of them, right? So they are the typical use cases of near real-time kind of a system, right? And they are the ones wherein you will talk about Spark. So a wide variety of people who were saying, you know, uh, that whether Spark is gonna replace MapReduce or Hadoop. I hope you got the answer, right? Now, next part about integration. So guys, I was talking about that Spark is a processing model, right? It doesn't care about the storage. So you can, the best, or I would say the most popular form of Spark in the industry today is using it along with Hadoop, because companies have invested their time, effort, and money on Hadoop. They are already having the clusters. They want to leverage them for Spark. So you can integrate Spark with Hadoop in two ways. You can use Hadoop only for storage. And by the way, on the record, let me tell, that is the most popular combination which is there in industry today. Okay, you typically want to use Hadoop for whatever it is best for, right? You get the assurances of fault tolerance in the terms of storage by HDFS. That's the best thing which you can get. And that is something if you leverage, then that is the first statement. You can use Hadoop only and only for storage and use Spark only and only for processing. That is most popular combination. In order to achieve the first thing, you don't even need yarn. Even if you have the old version of Hadoop, you know, Hadoop 1.x or something, it can work. The second one is Spark can use yarn. So you want to run Spark as a yarn job, like your MapReduce job. You want to do that? In that case, yarn will take over the cluster resource management. Your job of Spark will be a little bit slower. Let me tell, your job of Spark will be a little bit slower than without yarn, but in the bargain, you will get the cluster, or you will kind of outsource your cluster resource management to a proven model like yarn, right? So those are the things, those are the trade-offs, those are the different things. And in, I think in our Edureka course, we kind of cover these both integration methods. In fact, we even cover the integration of Spark SQL with Hive. Okay, so that's an exciting feature altogether. That define something in Spark, get it in Hive. Define something in Hive, get it in Spark, sort of. So those are the integrations which we typically kind of do those things. So execution platforms, yes. So I was just telling you that Spark, you can use it along with Hadoop. It has its own cluster manager. You can even integrate it with another cluster manager called Mesos. However, we cover the standalone mode as well as on the yarn mode. We don't cover via Mesos because it's like it's not very popular, but yes, we do kind of, you know, give you enough directions if you really want to try your hands on those things. We do kind of provide some artifacts on those lines, but we don't really cover them in the course, right? So that was about their integration. When it comes to modules in demand, I think I saw some of the questions at the start. What is in demand, right? Well, to me as a technologist, if you ask, that's an invalid question, because I would not like to learn something because it is in demand. I would like to learn something because of its capabilities. Okay, and hence, but still, it's a valid question, I think, from whatever perspective. That is something you can clearly see, that core API. It's the highest thing in demand. Streaming, that's the next thing. Well, MLab, there is a huge interest altogether, okay, on it. However, uh, you know, Spark SQL is something which is like another big thing altogether. And Graphx, well, it is in the nascent stages. It will take its own time to come out, right? So new features I just discussed, it's kind of a recapitulation. Data frames, Spark are yet to be released, sort of. When I say with 1.4, just that we are referring for the data frame part. Support of data frames altogether at least has been introduced. Now they are introducing kind of, let's say, full-fledged language support altogether. Machine learning pipeline, external data sources. So as of now, Spark has got excellent integration with Hadoop. You know, your local directories with your sockets. Uh, However, the integration with you know, the sources like Cassandra, etc., there are not inbuilt connectors. Of course, some of the programming is required by individual people. So they are some of the things which are like, you know, you can clearly see that this is an ecosystem which is very, very active. You know, every with every release they kind of release one connector or the other, wherein it can be used out of the box. So, yep, how is Spark in the industry? The fact that there are more than 120 people right now, right? I think how that tells you how is Spark in the industry, right? That is something which should be the biggest testimony. But yes, coming back to the slide, I have to respect this also, right? More from the perspective of, let's say, there are a lot of companies which are still evaluating because many of them don't even know. And in fact, doesn't look nice or doesn't sound nice. But there are companies who have started their big data center of excellences without even knowing what to do with it, right? So there are majority of companies which are in that phase, but there are 13, almost 13%. There are very few companies which have started using it in production, and most of them are using core Spark because that's the most common or most stabilized part of it, right? Well, 20% are planning to use Spark in 2015. Don't go with much with that, but I would say please look at this particular part. Top three languages: Scala, Java, Python. Scala most, Java. A note for the people who are, by heart Java programmers or hardcore Java programmers. You want to use Java? Go ahead and use it. But use Java 8. Don't use the versions before that. Your programs will be awfully long. Okay? So that's the only thing which I would like to say at the end of it. Well, I tried my level best to answer questions as much as possible. Well, guys, I hope that is something which was a good uses of your time. There are people who are asking about Mesos versus Yarn. Well, Yarn and Mesos both are the resource managers, cluster resource managers. Just that Yarn is very popular because of Hadoop. Mesos is not that much popular, but they do the similar kind of thing, right? Guys, thanks a lot for your time, for that patronage. You took quite a lot of time. Do fill the feedback. That's all is my request. Okay. And if it excites you, let's meet sometime in the class. Bye. Bye for now, guys.